The outbound principle is boring. Let's talk about why it's like that. It all began with spectral lines. Scientists observed that on the continuous spectrum, or the complete range of visible EM wavelengths, when a gas is heated on its own, it emits light at a specific wavelength. But when the same gas is being shined by a light source, it absorbs light at that same wavelength. The lines that represent that specific wavelength on the spectrum are called spectral lines. However, they didn't have an explanation for it until Max Planck came in. While working on the blackbody radiation, he proposed that energy emitted is in discrete amounts rather than continuous amounts, unlike what classical physics had assumed. The relationship of energy and light and its wavelength is given by this formula. Later, it was understood that the spectral lines exactly correspond to the difference of E, or in simple terms, when the electron jumps from one shell to another. This is where Schrödinger comes in. By means of variable separation, we get two functions from the wave function. One is time-dependent, the other is not. We will go directly to the time-independent equation because after solving, we will yield the allowed energy and what wavelengths of light will appear as spectral lines. The equation can be written as Hamiltonian psi equal to E psi. It means that when the Hamiltonian is acting on the eigenfunction psi, it is equivalent to psi scaling by the eigenvalue E. For an analogy, think of the Hamiltonian as a machine that transforms function, just like matrices to vectors. If that function is an eigenfunction, the machine doesn't change its shape, it only scales it. What the Hamiltonian actually does is beyond the scope of this video. And this is equivalent to the same eigenfunction being scaled by a scalar scale factor called eigenvalue. For multi-electron atoms, you don't just solve normally, we use approximations. But luckily for hydrogen, you apply it to the three-dimensional spherical coordinates. Separate it into two equations. The angular equation gives m and L, and the radial equation gives n. The SPDF comes directly from L, in which S is 0, P is 1, and so on. And M depends on L because from the angular equation, we get this. So L equal to 1, we get -1, 0, 1. There are 3 orbitals. Since there are 2 rooms, you can fill in 6 electrons because 3 times 2 is 6. If L is equal to 2, we get -2, -1, 0, 1, 2. 5 orbitals. That means 10 electrons can be filled in. For the energy levels, you can't use the radial equation of the hydrogen for this one. Therefore, it is the case of multi-electron atoms. I will skip this part because it's too advanced and requires computational cost. Now, after approximating, you will be able to fill in the subshells in order of the increasing energy level.